Good morning, my dear children. You are most welcome to the chemistry class. I know you after the biology class. Okay, we'll make this chemistry class a little bit relaxed. But chemistry's subject is very interesting subject, just like the biology. In biology, you study about your own body, the mechanism, how it works. And in chemistry, apart from the body, we learn about the things surrounding us, why certain things happen, how certain things are happening, and the explanations you can find in chemistry. So, dear children, before starting the lesson, you will see on the screen today's topic, periodic table. In Sinhala we call Avartita Vaguva. It's a chart. Okay, I'll explain you later. And if you have any hearing problems, just go to the join audio on your phone as explained on the screen, and then press that one, and then the dialog appears, call over internet. Just press that, then your listening problem will be over. And next, now you will see on the screen, if you want to contact me, if you want to ask me any questions, on the right side at the bottom there are three dots saying more. Just touch that one, and then the dialog box appears, and in that it says chat. Just press that one, and then you can type whatever the question you want to ask me during the course of the lesson. Okay? Now, dear children, today's topic, as I told you, is periodic table. There's a person we cannot forget. His name is Dmitry Mendeleev. You see his picture on the screen. Dmitry Mendeleev. Now, he's a Russian scientist. So what did he proposed? He put all the elements in order. In order of what? In order of atomic number. What is the atomic number we learned last week? It is the number of protons inside the nucleus. Number of protons. Okay. And also he grouped these elements according to their characters or the behavior in certain groups, certain families. We'll discuss this later. Now, I just want to revise you, make a revision of last week's lesson. If you have the notes, just take it. Have your lessons notes in front of you. Okay. Last week we discussed about the surrounding, including us, all what is in front of you and far away, that consists of matter and energy. Matter and energy. You know very well, I gave you the notes last week, what is matter and what is energy. Matter is anything that has mass and volume. And energy does not have mass and volume, okay, but it has the capacity to do work, capacity to perform, move things from place to place. Now see the fan over your head, it's moving. It's because of the energy called electricity. You have the light, you have the sound, all these are energies that does not have matter and volume. Okay. Now, these energies are mostly discussed in physics. Now in chemistry, we discuss mostly about the matter. Right. The matter. The basic unit of matter is atom. Atom is the smallest piece of an element. Now, can you remember last week we discussed about the structure and the properties of the atom? Structure. Okay. Now, just see on the slide, atom has a nucleus in the center. nucleus. It contains protons and neutrons. And electrons are orbiting or moving around the nucleus. So, this is the structure of the atom. It has a nucleus in the center and electrons are moving around. So, the nucleus contains the protons and neutrons. Okay. Next, we are going to see these subatomic particles called neutrons, protons and electrons. Okay, dear children, if I say this, sometimes it may surprise you. The whole world around us is basically made of three things. All these different things are made of three things. What's it? Protons, neutrons and electrons. So if you understand the behavior and the properties of these three subatomic particles, I'm sure the chemistry will be very easy for you. Now see you on the chart, just refer to the chart, you see proton, very simple. It has a charge, positive charge, and it has a mass. Relative mass is 1. Why we call relative? Because we cannot compare with grams. It is so small, so minute. So we'll compare with another particle that has of same proportion. Okay, we compare with neutron. When you compare with neutron, the relative mass is 1. When you think about the neutron, its properties, it has no charge. And its mass is, again, relative mass is 1. Electron has a negative charge, and a very minute mass, even compared to the proton and neutron, it is 1 upon 1836. Now you see this in the chart. Okay. Now, can you remember Niels Bohr? He explained that the electrons are not just moving. They are in different energy levels. He named them 1, 2, 3, 4. And OKLMN. We learned that the K energy level can have maximum 2 electrons, L energy level 8, M energy level 18, and so forth. And also in chemistry, can you remember last week, we learned that we are not going to write the full names of the elements because it is difficult. It's very complex. So, we write the symbol. That is the first letter of the name only. Say hydrogen, H. Carbon, C. Oxygen, O. The first letter in capital. But sometimes there are 2, 3 elements coming with the same, beginning with the same alphabet. So we use the second letter as well, but we use the second letter simple. Now on the board, it appears helium. H is capital, E is simple. And also 2 numbers, 2 and 4. What is 2? That is the atomic number. And on the top is the mass number. What is the mass number? It is the number of protons and neutrons in the nucleus. Now, if you consider only an atom is neutral. That means it has equal number of protons and equal number of electrons. To cancel out the positive charges, it has the equal number of negative charges. Those electrons are moving around. Okay. Now, on revision, can you remember some of the scientists we discussed last week who contributed to this explaining atom? John Dalton, What did he say? He said atom is the basic unit, smallest unit of an element or anything. The smallest piece that we can break is the atom. Smallest piece is the atom. And also J.J. Thomson, he also tried to explain the atom. He said the atom is like a pudding, like the resins and pieces of fruits that is in a pudding. These subatomic particles are within. Subatomic particles are within the atom. Okay. Now someone is asking about the Ernest Rutherford. Okay. Nishika, O'Neill. Right. Now Ernest Rutherford put forward a planetary model. That is like the planets are moving around the sun. Electrons are moving around the nucleus. Now that is the planetary theory. Very easy. That name of the theory relates to what it says. And later, Neil Bohr, he further explained that the electrons which are moving on certain energy levels, said KLM, and he also mentioned that each energy level can accommodate, there's the number of electrons that it can accommodate. K can accommodate 2, L can accommodate maximum 8, M can accommodate 18, and so forth. Okay? Now, you already know what is atomic number and what is mass number. In front of you, I think the notes that you have, it clearly says atomic number is the number of protons. Protons means plus charges in the nucleus. The number of protons or the atomic number is the primary cause for the character of the element. If it has one proton, it is hydrogen. If it has two protons, it is helium. If it has three protons, it is lithium. Completely different elements. So, the number of protons or the atomic number is the main reason for having different elements. How many elements do we have in the periodic table? It's around 118 so far. Maybe they will discover more. Okay. Now for your London O-level, we have to study about only first 20 elements. Very easy, very easy. Okay. Now the mass number is the number of protons and the neutrons in the nucleus. Can you remember last week we mentioned about isotopes? Isotopes. Now, I think those who are not familiar with this, you can write down this one. Isotopes. Go to the screen, write down isotopes. And the description, okay, it appears in an element of an atom having same number of protons. Same element, maybe in different atoms, it has same number of protons, but the number of neutrons, it vary. So what happens? If the number of neutrons vary, the mass number varies. And it's called isotopes. And it's called isotopes. Okay, on my next slide, you will see the hydrogen. In blue color, you see the proton. One proton. Hydrogen has one proton. So if it has one proton, we call hydrogen. And if it has one proton plus a neutron, still it is hydrogen, we call deuterium. The mass number is 2. Suppose hydrogen has 3 electrons. The mass number is 3. So we call it tritium. So remember, an atom or an element can have different number of neutrons. Now see the next one, lithium. For example, lithium, the number of protons, atomic number is 3, but the mass number differs. 6, 7, 8. That means on the picture you see it has 3 neutrons, 4 neutrons and 5 neutrons. So the mass number varies. See the next example. Carbon. Carbon is having atomic number is 6, but in these 3 atoms the number of neutrons, it varies. So the mass number becomes 12, 13, 14. I'm sure now you understand. Now this is all revision. Okay, children? We also learned about the configuration, electronic configuration. Right. What is electronic configuration? That is, we learned in an atom, there's a nucleus, electrons are moving around the nucleus. So how these electrons are moving, that is the arrangement of electrons in an atom, is called electronic configuration. Electronic configuration. Now we will go back to the slide. Now we'll go back to the slide and you will see electronic configuration we can draw or we can write. When we draw, we have to draw the nucleus and around that circles, first energy level, second energy level, and keep on filling the energy levels. First can accommodate only 2 electrons and the second energy level up to 8 only. Now if you write, you see in the carbon 2, 4 we write. That is when we write. So now we are finished with the revision and now we are coming to the topic today, that is the periodic table. I told you Dmitri Mendeleev, we cannot forget, he proposed a chart we call a table, in singular we call Vagula. Okay, how it is filled? It is filled with the name of the elements, that is with the ascending number of atomic number, ascending atomic number, that is beginning from the smaller one to the bigger one. Okay, and he also grouped them in certain groups. We are going to learn about this. Now see in my next chart, there's a chart. Okay, 1, 2, 3, 4, like that. That's a chart, ascending order. And we are going to the next slide. That is the present periodic table, the 20 elements, first 20 elements which you are going to learn. Now we have to draw this one quickly. I'll give you a little time. First, on the top are groups 1, 2, 3, 4, 5, 6, 7, and you see the last one is not 8, it is 0 on the chart. And there are 4 periods mentioned, 1, 2, 3, 4 periods, and you see the hydrogen says 1, and there's a mistake on the 7th chart. There's again hydrogen show, don't write this one, and the second helium on the 0 group, and lithium you can mention 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 6, fluorine 7, neon 8, and so forth. And you can keep on filling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20. And on the bottom it shows, right, 2, 1, 2, 2, 2, 3, 2, 4, that I will explain to you later. Just write down note down this periodic table quickly. I'll give you 2 minutes. Okay. Someone is asking me what is the textbook book Edexcel chemistry. You can purchase this from the office, those who can, and this is very important. If you can have the textbook, it's going to help you a lot. Okay, right. Have you finished with the chart? Now I am going to show this chart in colors. You see there's some squares in the middle which were not in the previous one. Okay, forget about those things, we'll learn later. Now there is the first squares, it is shown in red color. Next one is in brown, yellow, green. Now these columns, or we call groups or family, these are vertical columns are called groups or family because all the elements within that group show same behavior, same character. So if you know the first element, we can predict what is on the elements that is below, how they behave. And also something very important, this you have to keep in mind, the number of electrons in the valence shell. What is valence shell? Valence shell is the last energy level, last utmost furthest from the nucleus. The valence, the number of electrons in the valence shell. Okay, now these are groups. Okay, you remember? Because the elements in the group, they show the same behavior and also they have the same number of electrons in the valence shell. For example, the first period, first group, they have 1 electron in the valence shell, outermost shell. Group 2, they have 2 electrons in the outer shell. And the third group, they have 3 electrons in the valence shell. Fourth group, what is in green color, it has, there's a power, children, there's a power shutdown, there's a power cut. Okay, children, the power has resumed and we will be starting. You can join with the same link which you used earlier. All the children are joining in. I'll give a few minutes for all to join in. Right? Okay. Now, we were discussing about the groups in the periodic table. Now, we'll go to the next slide. And that is periods. This is something very interesting. It shows in the horizontal rows. That's all periods. Now periods also have something significant. That is the first period, second period, third period. It shows the number of energy levels that the atom is having. Now in the first energy level we say hydrogen and helium. It has 2 electrons only. So this has an extra square column, just forget about it, right? And the second energy level in brown color. Okay, now in an energy level, in a period, it from left to right, it keeps on filling, adding 1 by 1 electrons as the atomic number increases. Okay, we'll go to the next slide, children. Now this is the first 20. You see the atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and the relevant elements. These are in ascending order. Right. With the previous chart which you have written down, if you have anything more to write, just complete it. I'll give you a few seconds. Right. Now we will move on to the next slide, and this is very important. Some notes you have to write down. Okay. This is about the periodic table. You can look at the screen and write down, or I'll speak to you, then at the same time you can write. Periodic table. It's a table of elements arranged in order of ascending atomic number. It's a table of elements arranged in order of ascending atomic number. Periodic table consists of columns and rows. You already know about it. Now about the vertical columns for the groups. Vertical column in the periodic table is also called a group or family. The group number represent the number of electrons in their valence shell. Within brackets, except helium. I'll explain to you that later. Except helium. Next line. They have similar behavior or similar characters. They have similar behavior in bonding. We are going to learn that later. Bonding. What is bonding? In bonding. Next line. A group has common names. Example, halogens, noble gases, alkali metals, and so forth, that I'll explain to you later. Okay. Now these are the groups. Now we are going to write down about the periods. Horizontal rows, flat. Horizontal rows of the table are called periods. A period has same number of electron shells. The period within brackets, elements in the period, we can write elements. They have the same number of electron shells. In a period, the elements are in ascending order of atomic number. Ascending order of atomic number. Okay. In a period, to the left side are metal elements, and to the right are non-metal elements. metals and non-metals. Loha saha aloha. I think you have already learned about these things in your previous classes in grade 7, 8. What is metal and what is a non-metal. Anyway, I am going to explain to you as well. Right. Now we know something about groups and periods. This is a simple table. Now I am going to show you a complete periodic table with having all the 118 elements. Now this table you should purchase from a bookshop, or you can draw it yourself or download it from the internet. You must have it with you from my next class, the full periodic table with colors, because then easy for you to understand. Okay, I'll show you the full periodic table. Now you see this in different colors. Just to make you understand, you see the first column in yellow and green color. Why it's green? Okay, although hydrogen is in the first column, first group, it is different. Hydrogen is a gas and it does not show any metallic qualities. It's not a metal. But all the other elements, lithium, sodium, potassium, rubidium, all these are metals, they are solids. We call this first group alkali metals, very reactive. And the second group in green and blue color, the elements in that group are named as alkali earth metals. They are also reactive. All the elements in that group have 2 electrons in their valence shell. Now, in brown color, you see quite a number of metals. We call transition metals. Now, this is not in your syllabus, but I am just explaining to you. These are transition metals because later at the A level you are going to start, apart from the energy levels, what we learned KLM, there are also sub-energy levels. Sub-energy levels. That is bit complex. That has SPDF filling system with a law called diagonal rule. That does not include you in this syllabus, that we can learn later. So the elements in this group are within the D shell. So they have different qualities. Now next you have the blue color. Those are poor metals. What is poor? Poor and rich. Okay. The metallic, the qualities of the metal, they show the behavior of non-metals and metals as well. So we say it's poor metals. And on the last column here, it's in brown color. Those are noble gases, unreactive. We are going to learn one by one. And the just column in front of that, fluorine, chlorine, bromine, iodine, acetylene, that is called halides. All those elements in that 7th group, they have 7 electrons in their shell. That is 1 electron less to fill the energy level. Right. Now I am going back again to the next slide. Just see hydrogen. Atomic number is 1 and 1 electron is moving around. What is that? This is electronic configuration. We have put a cross to show the electron. We can put a dot as well. So we say dot or cross diagram. This is, and also helium. You see in that one. And I'm going to move on to the next slide. Let's tell you, looking at the number of electrons, can you tell me what is the atomic number of this one? First energy level 2, second energy level 6. So it has 8 electrons. That means how many? Atomic number is 8. How many electrons in the valence shell? There are 6 electrons in the valence shell. How many more it need to fill the energy level? 2 more. If it has 2 more electrons, it can fill the energy level. Now you see carbon. Carbon. You see in the first energy level 2 electrons, and on the valence shell, the last energy level, 4 electrons. What is the atomic number? 2 plus 4, 6. 6 is the atomic number. I'm sure you understand. Okay, I'm going to move on to the next slide. Just look at it. You will understand. Right? See neon. It has 10 electrons. That means outer valence shell is full. And on the picture above, it shows 6 electrons in the outer shell, which you learned earlier, and 2 electrons in the inner shell. 6 plus 2, 8. And that is oxygen. Right. I'm sure now you understand. Okay, now we are going to move on to the next slide. And I am going to try and show you this as well. Right? Okay. In short, this is the shape of our periodic table. This has columns to say 1, 2, 3, 4, 5, 6, 7, and this is 0. These are columns. Okay. Now these are periods. First period, second period, third period. Now you must study the first 20 elements by heart. Hydrogen, helium. I'll give you a little poem for you to keep in mind. Okay, just see. Little Benny boy caught naughty pussy fooling Millie. Little Benny boy caught naughty Ossie. Kuda Benny boy allagatta දඟකාර ඔසීව නෙලීට විහිළු කර කර ඉඳලා. Okay. Little Benny boy caught naughty Ossie fooling Nelly. Likewise, the third row. I am leaving it to you for you to design whatever the rhyme or a poem to fill it in. Right, now I am going to move on to my screen. You will see the elements on the first group. The element is on the first period is left out because hydrogen. Although it is there, it does not really belong to the first group. So starting from the second period, it's all colored. Roughly you can Draw this one, draw the first column only, leave out the rest, and just write down few qualities of the elements in this group. Okay, first group, we call it alkali metals. It's right on the top, alkali metals, that's the name. All the elements in that group are named as alkali groups, like Fernando, Perera, Mendes. Family names are there, no? So likewise, this is the alkali metals, name given for the elements in that group. They are very reactive. Write down, in short, I'll give you. They are very reactive. Outer shell, they have one electron. Outer shell, they have one electron. Electropositive. Electropositive. Do not occur freely in nature. We can't get it in pure form from the nature because they are very reactive. They always react with other elements of oxygen. Do not occur freely in nature. They form strong alkaline. Alkaline means bashmika, not acidic. आम लिखने में बाष्मिका. Alkaline hydroxides. Okay, in short, I gave it. From looking at the periodic table, you can write down the elements in that, like lithium, sodium, potassium, rubidium, cesium, and francium. Even on the bottom. Those, fill it up, okay? Now that is the first group. Now we are moving on to the second group. What is the name given? Family name given. Alkaline earth metals. Right on the top, write down. You can write down. Alkaline earth metals. Two electrons in the valence shell. There are two electrons. Group number is 2, so they have two electrons in the valence shell. Very reactive. Therefore, very rarely we find in pure form. Pure elements very difficult to find. Therefore, very rarely we find it in pure form. Form basic hydroxide. Form basic hydroxide. Right? And you will see on the bottom, to fill it in, you can refer the periodic table and you can put the atomic number as well if you like. Like barium, magnesium, calcium, strontium, right? Beryllium, magnesium, calcium, strontium, barium, radium, and so forth. Okay? Now children, I am going to show you in my next slide transition metals. Now this is not important for you, but just for your information, I am just putting forward transition metals. This is within the 20 elements that you are going to study. This is not included, but you can write the name of this is transition metals. Transition metals. Just one or two characters. Atoms have incomplete D subshells. Atoms have incomplete D subshells. Just that enough, because no need for you to know further. Now we come to poor metals. Poor metals. Next to that, unfortunately, most of you may not be having the periodic table today with you, but when you have the periodic table, you can refer these poor metals. We are going to write a small note on these poor metals. They are common to most metals. Okay, write down common to most metals. Like other metals, they are common. What are the common features? Malleable, ductile, conduct heat and electricity. These are the qualities of the metal. What are the non-metallic qualities it show? Okay, it shows but lower melting and boiling point. But lower boiling and melting and boiling points. Soft. Next one is, it is soft compared to other metals. Other metals are hard. Now these are comparatively soft. Soft compared to other metals. Okay children. Now this is which I told you earlier about what you have learned earlier in your classes about the metals and non-metals. What are the qualities of the metal? What are the qualities of non-metals? Now, I am giving you a table on this one. You got to write it down. Okay, just concentrate on the screen. I am going to read as well. Just divide the page into two. Metals on one side and non-metals on the other side. Now to the metals it comes, if you refer to the periodic table, alkali metals, alkaline earth metals, transition metals and poor metals. I'll go to the next slide and come back. Okay, quickly. Just see the next slide. It's full of colors. Light brown. All these are metals. And blue color. Blue color, those are non-metals. Just few. And there's pink color. Those are called metalloids. What are metalloids? They show in between metals and non-metals, the qualities between non-metals and metals. So they are called metalloids. So you see in pink color. Now you understand. Although hydrogen is on the left side, It's also blue color. Can you see? That's a non-metal. Okay, I'm going back again to the previous slide. On non-metal side, right, non-metals are halogens, non-metals, halogens and noble gases. On the next line, elements onto the left side of periodic table. We saw that the periodic table, the elements to the left side, all the elements except hydrogen, they are metals. Okay, on the other side you write elements onto the right side of the table. Now the metals, next point, conduct electricity. Conduct electricity. You got to write down quickly because we are running out of time. Right? And on the non-metal side does not conduct electricity. This I will explain later. Why these things happen. I told you how, why and what. All the things have been explained in chemistry. And next, malleable, ductile and luster. When you cut it shines. Luster means it shines. Surface shines. Malleable, ductile and luster. Okay, we are running out of time. If you write quickly. On the non-metals, brittle, low melting and boiling points, except carbon. Metals form ionic compounds, electropositive. I'll explain to you later what is electropositive and electronegative. Okay. On non-metal side, form covalent ionic compounds, electronegative. This chart I will forward to you in my next. I will upload it so you can write it, complete it. And now we are going to now in a little while we are going to shut down the class. You can refer to my Google class as well. I will upload the notes, and as well as this whatever we discussed today will be you can have it from the Zoom class. Okay, so we'll see you next week and be ready with the periodic table. Thank you.